Hi, welcome to Chapter 8, Descriptive Statistics. This is the first chapter that we are dealing with statistics, and you might have known about statistics a little bit from your previous math classes, but anyhow, let's look at what statistics is. So, simply put, statistics is the study or the science of data, right? Knowing statistics, it is a very useful tool to analyze and organize data in a way that would be helpful to answer any questions that we ask, right? So, normally when we have a question, what we would do, especially scientists, they would try to come up with some research method, and from on their research they would try to collect some data, and hopefully those data can help them to draw some sort of conclusions, right? But what's data? Data is a collection of facts. So those data could be frequencies, could be measurements, could be words, observations, or just some descriptions, right? And hopefully the scientist or whoever is doing the research can use those data to somehow draw some kind of conclusion, and hopefully make a projection in the future, right? In this chapter, we will be talking about univariate analysis. We'll only be talking about univariate analysis. Uni means one, and variate involves some sort of variable. So univariate means we are only involving one variable. So for example, if I would like to find out the height of the students in a grade level, so maybe for example grade 11 or grade 12, I want to find the height, right? So that would be only one variable. In this case, that would be height. Or another example would be number of patients in the hospital in a week. So in this case, there's only one variable, which is the number of patients. Okay. In chapter 10, which we will come across later on, in chapter 10 we'll be talking about bivariate analysis. Bi means two, right? So in that chapter, we'll study the correlation between two variables. So for example, if maybe I want to find out if there is some sort of connection or relationship between how many hours students sleep and their heights, right? So that will be the correlation between the two variables, okay? But in this chapter, chapter 8, we'll only be looking at univariate analysis, which means only one variable, okay? All right. When we talk about data, we have two types. The first type is qualitative, where most of the responses are in words. And the second type would be quantitative, where it will involve numbers. So the responses of the information can be counted or measured, right? So examples of qualitative data would be, what's your favorite color pen? So the response would be blue. How do you go to school? Maybe by taxi, by BTS, or what is the brand of your laptop? Dell, a Mac, or whatever. And you can see that the responses to these questions are all in words. So these are qualitative data. All right, the blue, the taxi, the Dell, those are the data that we collected. And since they are in words, they are qualitative data. Now, some examples of quantitative data. For example, how many pens do you have? So maybe 3, right? How long does it take to get to school? 15 minutes. How long do you spend on your laptop in a day? 5 hours. So all these responses are in numbers, right? So the data that we have, the 3 pens, the 15 minutes, the 5 hours, they are considered as quantitative data. Okay. Now, since this is a math class, we are more interested in the number type of data, or in other words, the quantitative type. So we'll look into it. There are two categories for quantitative data. The first one is discrete, And the second one is continuous. Okay, so if it's discrete, it's something that can be counted, or a fancy word would be frequency. Okay, so for example, how many CDs do you have at home? Number of CDs, or how many siblings, or how many family members do you have? Those are the responses to that would be countable, right? So it would be in terms of frequency, right? The second type is continuous. So for continuous data, it is something that can be measured, okay? And which means you could have fractions or you could have decimals. So in your chemistry or physics class, you take a lot of measurements, and all of those data would be considered as continuous data, okay? So some examples would be length, temperature, weight, time, etc. Okay, so there are two types: discrete and continuous, and we represent them in using different visual aids. Right? We have came across bar graph and histogram when we were young in our math classes, right? But we don't really, we're not sure if we really understand the difference between them. They may seem very similar, but they are actually quite different, right? So for discrete data, which is something that can be counted, we use bar graphs. And for bar graphs, a typical bar graph would look like that on the first graph. That's a bar graph, right? So in this case, we have comedy, we have action, romance, drama, sci-fi. So we have different types of movies. And we could be asking around people. So we have 4 people like comedy, 5 people like action, 6 people like romance, one likes drama, and 4 people like sci-fi. Right? So they are discrete because we cannot really mix them. There's no continuation between them. So that's why the graphs are separated. Okay. So for discrete data, we use bar graphs. Okay, now the second one, the one at the bottom, that's a histogram. And we use histogram to represent continuous data. Okay, so as you can see here, there's no gaps, right? There's no gaps. And if you look at the x-axis, you can see that it is a continuation from 0 to 10, 10, 20, 20, 30, 30, 40, all the way up to 100. There's no gaps between them, right? So in this case, we can look at them as categories, right? And the categories are in continuation, okay? And one very important key point for histogram is that the intervals must be constant. So in this case, my first interval is from 0 to 10. My second interval from 10 to 20, 20 to 30. So they all have intervals of 10 points, right? So if a student, let's say if a student has a score of say 75%, right, 75 points, then the student would fall under this category. Okay, in this case, we have 20 students. It seems like we have 20 students with the score of with the score between 7 to 80 points, right? Another thing that I need to point out to you guys is when we are reading the histogram. So let's look at the first category, 0 to 10. If a student has a score of 10.2 points, so that student will be here, right? What if a student has 10 points, exactly 10 points? Where does that go? Does that student go under the blue category or the red category? So when we are reading histogram, the upper bound, it is not included. Okay, so if a student has a score of 10.5, then if a student has a score of 10 points, then that student would fall under the red category. So which means everybody in this blue category has 0. It could be 0 all the way up to 9, 9.9 or 9.99, but not 10. Okay, 10 starts from here. So this one starts from 0 all the way up to almost 10, not including 10. This is starting from 10 all the way up to 20, not including 20. For the green one, the green category starts from 20 up to 30, not including 30. The purple one starts from 30 all the way up to 40, not including 40. And the same pattern goes on for the remaining categories. Okay? All right. Let's take a look at an example. So this is example 1 of your textbook in chapter 8. They gave us a bunch of data, and this student is just counting how many cars pass by his house in 1 minute. So the first minute there were 23 cars, second minute there were 22 cars, third minute another 22 cars, the fourth minute another 22 cars, so on and so forth. So he recorded, this is his raw data, right? And the question wants us to display the data in a frequency table, which is what we have on the left hand side, and a bar graph. So normally we need to create a frequency table first before we can create a bar graph, right? So you can see that 20, the least amount of cars in 1 minute is 20. So that's why we have a 20 here. So we have 22 20s. So in this case we're counting how many 20s. Like we mentioned just now, frequency is just a fancy word of how many times it happens. So we have 2. For 21, I have 1, 2, 3, 4, 5. All right, so I got 5. For 22, I have a lot. 1, 2, 3, 4, 5, 6, 7. All right, so 22 we have 7, and we basically just count how many for each. How many? What's the frequency for each of this? And then just write it down. Then we create our bar graph, right? So since we're counting here, this would be a discrete data. And also, we cannot have, for example, 21.7 cars in 1 minute, right? We cannot have 24.3 cars in 1 minute. It's either one full car or no car. So it makes sense that the data we have here is discrete. Alright, that's why we have the gaps between the bars. Alright, now let's look at example 2 in your textbook from chapter 8. So here we're looking at the ages of 200 members. So here, all these numbers, we have 200 numbers here, and each number represents how old they are. Okay, it would not make sense to create a bar graph because I would end up with a lot of bars. Right? So for 20, I will have only 1 bar, and since I only have 1 member being 20 years old, that's 1 bar with a frequency of 1. Same thing with 22. 22 by itself, another bar, and frequency of 1. Right? For 25, okay, I have three frequencies. I have 3 members of 25 years old. But again, if I do that for the entire list, I'm going to have a lot of bars, right? And I don't want to do that. Instead, I'm going to create categories. So for my first category, it will be between 20 to 25, not including 25 though, right? So 20 all the way up to 25, not including 25. Second category is 25 to 30, not including 30. Third category, 30 to 35, not including 35. So these are intervals of 5 years, right? Intervals of 5. And what I do is, so 20 to 25, I'm just going to count it. 1, 2, 3, 4. So that's it. 25 cannot be there. So I have 4. There goes the 4. 25 to 30. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12. There goes my 12. And I just basically do the same thing for the whole list, right? Put them in the respective categories, and then make a histogram. Right, now that I have put them in categories, I have 20 all the way up to 70. This is all linked up. Right? This is all linked. So this is no longer a discrete data. We have continuous data. Okay, we are still counting here, but since we are putting them in terms of categories, and it makes sense that everything is sort of connected now. Okay. I hope you guys find this video helpful, and I'll see you guys in the next video. Bye.